the joint, that's the jam. Turn that up, play it again. That's the joint, that's the jam. Turn that up, play it again. That's the joint.
Okay, number 4 asks us to give the intervals on which the function is increasing or decreasing. Okay, so the thing is, when you look at a graph, you can tell whether it's increasing or decreasing depending on the slope of the graph. Okay, so for example, when we have something like this left part of the graph, right, we can see that obviously all the way down to this point right here, this local minimum, right, we have a decreasing function, okay? And whereas from that point up to this point, all the way up here, we have it increasing, okay? So then our function is increasing. And then we switch back down to decreasing, okay? All right, so our job, so like I said, this is a local minimum, right? So local min, and this is our local max, which isn't necessary, I'm just labeling them, just because. So now we're going to give the intervals, the x intervals they mean, on which the function is increasing or decreasing. So I'm just going to call it x and y. We don't have to even put that in, the x or the y. I'm just saying for referencing purposes. So let's do increasing first. So we can say, because there's only one interval here. So increasing on what? What interval would that be? As for our independent variable or our horizontal axis, this is about the point negative 1.5, I would say, in our x. So negative 1.5, and this one's 2. Okay, so increasing on the independent variable axis of negative 1.5 all the way up to 2. Okay, so that's, and we know this because there was a positive slope, right? And then on the other hand, we have decreasing on which intervals, we're actually going to have 2, right? So the first one is going to be from negative infinity all the way up to this negative 1.5, right? Because the graph just continues on, and it came from the left. So if we move left to right, it's just going to be from negative infinity all the way up to this point, and then it stopped decreasing for a little bit. And then it went to increasing, so we skip over that, and then decreasing, another interval on which our function is decreasing, is 2 all the way up to positive infinity, right? Because this is just going to continue on downward. And then the way you connect two intervals to disjointed intervals is by putting the union sign, the symbol for union in there. Okay? All right, last question, number 5. They ask for each table, well, for the table below, we only have one, select whether the table represents a function that is increasing or decreasing, and whether the function is concave up or concave down. Okay, so here we see, well, this is actually supposed to be just negative 100. It got moved around weirdly. But anyway, so this is when x equals 1, h of x is negative 100. When x is 2, h of x is negative 50, 3, negative 25, 4, negative 10, and 5, 0. Okay, so we see that as we progress, as the x values increase, our independent variable values, our h of x is actually becoming less negative, right? So as we go down, we're becoming less negative, which means that our values are increasing, right? So we already know that our function is increasing, so we can say that function is increasing. So that's that. And then we have to determine, okay, is the function concave up or concave down? And how do we determine that? We're just going to stick on an extra column here. So let me rewrite these actually. So we have x, h of x, and then we're going to study the rate of change, right? So we have 1, 2, 3, 4, and 5. Then our h of x is negative 100, negative 50, negative 25, negative 10, and 0. Okay, so let me study the rate of change. So as x jumps from 1 to 2, our h of x went up 50, right? Because it went from negative 100 to negative 50. So that means it had to change by 50, positive 50. So then the next jump is going to be plus 25. The next jump is plus 15. And the last jump was plus 10. Okay, so now we study, okay, what is our rate of change doing as we move along with respect to x here? And that the answer would be, well, each time you're adding less. So that means your rate of change is getting smaller, which means rate of change is decreasing, right? Rate of change is decreasing, which means that we are concave down. Concave down. Even though the rate of changes are positive, they're becoming less and less positive as our x grows, okay? So that's why it's increasing and concave down, all right? Okay, so that's it for our practice problems video for the section on rates of change and behavior of graphs. I hope that helps, and good luck on your homework.